down the button. Okay, cool. It's recording.
Okay. So, I'm gonna get into like how the ECU processes this a little bit, and then we'll go to the next topic. So I have two plots here, right? We have the cam, and then we have the crank. So crank will be up here. It's kind of hard to do this like without holding and waiting, so I'm just gonna go for it. Let's suppose we have a square wave like this, and then it's the gap right there. Okay. And then on the camshaft side, we have maybe like something like this. Oh, that's not good.
So do camshafts like to use VR more than Hall effect, and the cranks only use Hall effect?
Is 2x faster or what?
No, the camshaft is like
Slow.
half engine speed.
Maybe one on the cranks, two on the cam.
Yeah. So you might get something like this, where we hold because there's a gap in the wheel, and then it knows when to start the cycle all over again, or it knows what stroke we're on. Okay. In some ECUs, right, whatever this gap is here, whatever the gap is here in some ECUs have some sort of relation to TDC, right? But usually we want to know on like a crank sensor, if this is TDC, right? We want to know when the valve is opening, right? Because the camshaft is actuating the intake valve. Let's just say, for argument's sake, that when the camshaft tooth passes, it has a certain relation in position to TDC. I don't know if it's actually opening, but this just tells you when opening is going to happen, right? And then it'll do that again, something like this. I'll show you guys like a trace from Mtron. Is this connected to Wi-Fi?
Yeah.
Okay. You might see something, right? If you keep poking around your software, you'll see there's usually like an offset that you can program in the ECU that tells you, hey, I have a blank spot in my trigger wheel. What is that offset in relation to my TDC, my timing? That's important because that just tells the ECU every time it sees a blank spot on the trigger wheel, what is that in degrees to top dead center, right? And top dead center happens twice, right? One on the intake stroke, one on the compression power stroke, basically. Or sorry, one on the power stroke and one on the exhaust stroke, right? Intake is going bottom dead center. So, in reality,
Is that for like almost all engines? Most engines?
in reality, it's BTDC, right? Because it wants to open the valve
At TDC.
before it top dead center, or BDC, I guess. Bottom dead center.
So
Yeah.
is that rule of thumb just like for almost all engines?
The what?
That like intake happens during the first one.
Well, yeah.
And exhaust happens on the other one.
Well, no. The timing is fixed mechanically, either by belt or chain.
Yeah.
So, that 4 strokes depending on how many degrees are in between the belt or chain in relation to the crankshaft drive, the crank drive, whatever's at however it's fixed to the hub, you're going to get those 4 stages no matter what. It doesn't matter how many cylinders you have. You're going to get those 4 stages no matter what. Bottom dead center, we know that the intake valve is open and is about to close, right? You guys know that? Eric?
One more time.
Bottom dead center, right? The piston is acting as a syringe to draw air, right? That means that the valve is opened as it's approaching bottom dead center, right? And then when the valve is closed, it's going back to top dead center. What we want to know on the camshaft, though, is the point that we have on our camshaft trigger in relation to TDC, because it's also going to look at where is the point that we're probing and how many degrees is that off from when the intake valve on cylinder 1 is closing. If we know those 2 things, and the ECU can differentiate when on a falling trigger, right? Falling being like going down, right? A falling trigger going down. On a falling trigger, what is that difference? What is the relationship between those 2? You really shouldn't have like the camshaft triggering down while while you have the gap in the trigger wheel. You're gonna have a lot of issues there. It's literally anywhere but the -2 part, right? Because you don't want to confuse it. It's looking for gaps, looking for the gap, and it's also looking for the falling edge trigger. So between those 2, it's saying this is the position of the valve relative to top dead center or bottom dead center on the engine. I need to know the difference in degrees between the 2 so I can do what with the fuel? What do you do with fuel while the intake valve is open? You're gonna put some in, right? Right. So when we set up our Motec or our M-Tron, in relation to 720 degrees of the 4-stroke engine cycle, we're gonna tell it this has 6 cylinders. At this many degrees, you're gonna see cylinder 1 at bottom dead center. How do I know that? Oh, it's this many degrees away from the crankshaft. When I see this many degrees away from the crankshaft, I'm going to output, or I'm going to ground my fuel injector. When I ground my fuel injector, there's fluid pressure from the fuel pressurized at the gate, at the injector, right? And then once you ground that injector, you just atomize the fuel for a little bit. And while it's drawing in to bottom dead center, it's going to draw that air fuel mixture, close the valve, and what's going to happen on the next thing? It's going to squeeze it, right? That's right. The ECU wants to know, where is the crank, where is the camshaft, what's the difference between those 2, and when we know what's happening between those 2, we know when to squirt fuel. We know when to atomize fuel. Okay, and it does that not just for cylinder 1, but it does a mathematical relationship between cylinder 1 through 6 or 1 through 12 or whatever, however many cylinders your engine has. It's just going to take the 720 degrees in an engine cycle and divide it by n number of cylinders in the engine, and it'll repeat that, right, based on firing order. Okay, I saw cylinder 1. What's next? Cylinder 6. Okay, what's 720 divided by 6? Yeah, 120, right? So it doesn't know what cylinder 6 looks like. It just knows that cylinder 6 is firing. It's going to be the next one to repeat bottom dead and top dead center 120 degrees after it saw these 2 things that I just drew. Make sense?
So is it going to shoot the injector 120 degrees after the first one, or is it going to sense the second one and then shoot it?
Well, it doesn't have a sense. It's making an inference, right? Because we don't have. So if we sensed it, we would basically make. Yeah, let me ask you something. How would you know that it's sensing it? How would you know when it's sensing cylinder 6 then? Like, how do we set that up?
Maybe since you know the firing order. Oh, yeah.
Well, that's still an inference, but how do you directly sense cylinder 6?
You have to know. Yeah, you can't really.
No, you can. You put another crank sensor,
Oh, in the.
right? It's just another relationship for whatever you wanted to sense. All we did was replicate what we're doing for cylinder 1, but now we're just looking for cylinder 6 top dead center. Why that information is important, I wouldn't know. But the ECU is smart enough to make inferences. If it knows 1 and there's a mechanically fixed relationship, like hard boiled into the crankshaft, when 1 is coming up, right, 6 is also ready to come up again, and then 2, 4, and 3 and 5, like they're locked in forever.
Yeah.
Like, unless you blow a rod and you know
And
you
it's
change
unanimous.
you can change the firing order. It'll be like 1, 6, 2, 4 is gone out like SpaceX, and then 3 and 5 like, sure, but you guys kind of get the point. And so Eric had a brilliant question like a long time ago. It started with Bosch 60-2 technology. When you can track with more teeth when and where top dead center is, and you can isolate the cam on when injector 1 is going to fire more quickly, it kind of leads to what Eric was saying. How come Porsche or anything like Bosch related starts up fast? Well, it's able to sort and look at the data faster instead of like traditional non 60-2 back then. It has to go through all those waves of VR sensors and look for where TDC where the engine cycle is restarting. It's buried in a multitude of just all these crazy sine waves, and there's no way for it to know when it's stopping unless you're looking for like the slightest change in voltage or slightest change here, and then it does it again. It's really hard to count and register that and make a comparison to camshaft data when it's constantly filtering it out, to filtering through and signaling, processing the signal to even discern, to actually discriminate where cam is related to crank. But after Bosch did it's called quick start technology. Look it up, it's a Bosch patent.
That's why it's important to know like your engine specs when it comes to tuning, because you can kind of like follow these values into the ECU.
Yes.
But
Yeah.
Like when we went to the tuning with Casa, the guy was like, I don't know shit about the engine, and then Bo was just there like, oh,
Yeah.
they just kind of like figured it out. Like,
Well, you can make really good assumptions. Most 4 cylinders have the same crank design, right? So the firing order may be the same, right? The front and back ones go up, and the other 2 go down.
right, but like it'd be more ideal for you to like know all the engine
Yes.
specs, right?
Yes.
He was like, because I don't know the stroke, I don't know the bore or anything. I was like, oh.
But that doesn't have more relation. That doesn't actually do anything in getting it started, but getting it running well.
Yeah.
Will?
No, never mind. Sorry.
Okay. Everyone kind of understand that? I went a little too deep. I'll try to bring it back home. So now we're kind of at the switch types. Toggle, momentary, rotaries. They all do the same thing. All we're looking at are logic levels. So, for all of time, you might be seeing something like this, right? The ECU is just constantly plotting its own graph. Like this. Right? And we're looking for switch. So switches can do two things. Either it can close to ground or it can close up, right? Does anyone know what a logic level is? It's just the voltage level to trigger an input, right? So if I have 12 volts at my power source, right? And I have a switch, like I'm just gonna draw a quick battery here. Okay. Anytime the switch closes, right? Say here, it's digital input 1 or something, right? Well, anytime it sees a switch, or let's see, whoops.
What is this called again? The logic voltage?
Yeah, logic voltage level, like logic level.
Yeah.
Anytime we see like a switch, right? Digital, say you guys wire an AMP connector and you do that. Every time a switch closes to ground, or say you had another digital input where a switch is closing to 12 volt maybe, right? Anytime you close the switch, you know, you're going to complete the circuit. And you're going to trigger something high because it's obviously going to 12 volts, or you're going to trigger something low because it's going to ground or 0 volts, right? Your waveform that the ECU is just going to look at when this guy, at what point did you close the switch, right? And it might be different. There's a pull-up voltage in the ECU. There's a pull-up resistor that maybe is like at 5 volts. Maybe it's like constantly waiting, sitting there. And the moment it sees it dip because it got to ground, right? It's gone to ground. It knows for that span of time, that's when you held the switch. It's when you toggle the switch. That's where you momently trigger the switch. That's just binary logic, right? Anytime I close the switch, it gives you the square wave, and it's either 0 or 1, right? If it's triggering low, right, back to 0 state. Okay, but then if we're triggering high, say we got like, say we want to register an input on the ECU. Every time we see switch ignition input, we see 12 volts. That's just telling the ECU that maybe the ignition switch is on. Well, then maybe your logic level is changed where if it sees 0 volts, nothing's happened. But when it sees 12 volts, then it knows it's in the on state. Does everyone follow?
Yeah.
Okay.
And it has to see 12 volts, right?
Yes. And it's okay if it's not seeing a complete 12 volts. It's easy to go into the ECU and say, I have a threshold level. If I'm triggering something high, if it's anything over 9 volts, we're okay. You know, that's sufficient. You can do that. And then, so now we kind of understand binary, right? Like 0 and 1, on, off. Not grounded, grounded, right? Not powered up, powered up. Powered up being 1, not powered up being 0, right? So depending on how we arrange our system and how we want to trigger things, you can always configure that to whatever you want to manipulate that logic to serve a purpose for you. And so I'll give you guys 4 examples of switches. Toggle switches, you guys see it a lot, right? On like fuel ignition panels on race cars, right? They just stay in one position. You toggle it either one position or the other. Momentary, like push buttons. Anytime you're pressing and holding the button, it's true or 1, right? Or it's just completing the circuit for the time that you are momentarily depressing that switch or button, right? And then when you release, it's back to ground or your 0. Rotary switch. This one's an interesting one because you could do it another way. So a good example for rotary switch might be like boost level, traction control level, fuel map aggressiveness, right? Like different maps to tell the ECU like how aggressive of a tune you want. Like depending, like in a race car, like you want to do more power output, well then that will reduce your fuel economy, right? And stuff like that. So maybe at the beginning of the race you have the more conservative tune on position 1, but then near the end of the race you don't want to pit and you want to go for gold or go for podium, right? And you're gonna go to you're gonna crank it to number 4, the most aggressive map that gets you the craziest horsepower, but it'll burn like the most fuel. So like it'll change the way the car drives, right? And you're just gonna make a sprint for the last lap. That's a practical use.
Other examples like wipers, go slow, fast.
Yes, right. Depending on the position, on where you are, right? That'll tell the ECU like what position you're selecting, and it'll just provide a different duty cycle to the wiper. So, yeah, simply put, it's like this, right? And then you have low, medium, high, right? Maybe you have like your 0 volt, like this. I triggered a 0 volt because I don't like carrying a lot of 12 volt where I don't need to. You can just have less live running, right? Where you have live current, you're just gonna be consuming, or where you have 12 volts, there's always current there anyway. Costs less to complete a circuit with just simple analog circuits. So analog voltage. So maybe this is position 1, like high, this is medium, and this is low, right? So when I'm gonna make another wheel in here. Oops. Okay. When I'm turning it to high, right, and that selector gets completes a circuit with the pins at the high, right, it just closes the switch, and that goes to maybe 1 digital input. When I do it for low, it's the same, or low, it's going to be the same, right? That's another digital input. Medium is the same. I won't need to repeat that. You guys kind of get it. So these inputs will tell the ECU what states are defined. So depending on what state, right, if this is at 0 and this is 1 because I selected low, right, it'll say, hey, Kevin wants low wiper speed. So I'm going to give the wiper motor 12 volts PWM. I'm going to give him pulses like this. It's operating low. Okay. But then I switch it to high and I don't like that. I switch it to high and it's like, hey, Kevin wants all the power. Let's give him something else. So depending on the input states that you select, you can directly control what outputs you get. For every input, there's a output, okay? Now, that's pretty important to remember, so you're gonna keep that in mind for the next couple things. let's see, we did rotary, switch states. Have you guys seen this terminology before? No? Switch states are basically like combinations of switches closing, right? So single position, single trigger means you have one pole or one switch, and it's only triggered with one movement. Now you might have another pole that is another switch, but you can trigger both. What happened?
She's going out that thing?
I know someone's here or he's just walking away.
What happened? Eric, what happened?
Bill says someone's gonna come pick up some stuff.
Oh, okay.
DJ,
Oh, okay.
he says we should end.
Yeah. We're almost done.
So is the switch states like is it like if you're saying if like this happens then this will be true, I guess?
Yeah, we'll get to that. That'll be the next. I'm gonna cut it off at that point. We're gonna want to get into. I feel like this is in a lot already. Because I haven't even gotten to how relays work and stuff like that. Right now I'm just building it up. I haven't even gotten to physics of how that even all works. I'm just telling you guys this happens. You guys can take my word for it or not. You should be skeptical and check. But I'm not gonna get into the details of how transistors work and stuff like that. If you guys want to, you can read up on it and then we can continue that on another time. I just want to get through how all of these little Lego blocks work and how they culminate to something on a calibration or a config file on a PDM, on an ECU, so you guys can look at it and be like, when I do this, I can do this, right? When I hit this button, I want ejectocito, something. And this is the logic that will build up to that. So, where was I? Okay, we have two poles and we want to close two switches at the same time. Well, that just means I want one trigger to control two poles. So that's usually called something like DPST. And then when you have one of them, it's just SP, single position, single trigger, right?
Trigger or throw?
It's the same thing, same shit. Yeah. Yeah, so SPST and then DPST. And then combinatorically, you just add more poles and you mix up the amount of throw or trigger states, right? Where you have some things on and some things off. And usually that the combination of on and off is limited to the way the contacts close and touch once you're done with the throw, right? So you might have something that can turn three things on by just a flick of a switch. That just means that you're closing a switch to ground on three poles maybe, right? Or you're closing two poles but leaving one open. So, it's just a combinatorical thing, depending on what spec of switch you get. I think we should stop here because once we get into relays and transistors, they get a little spicy. So I'm not trying to fry y'all brain. let's just make a note that it's Friday, July 11th, and we've kind of stopped here.
Getting done Friday.
Oh, it's
Okay.
Free Slurpees Day.
Oh, for Slurpees.
Okay, so I'm gonna end the lecture here. I feel like that's a lot. I feel like I inadequately covered a lot of this. There's so much more to actually teach you guys about those stuff. But I'm just trying to hand wave it right now. So, yeah. There's so much stuff. Like I haven't even gotten to the physics of how that actually works. I could walk you through every derivation of how these actually work. And I can derive the equations with you if you want me to. Just like I can derive like Euler-Lagrange equation of motion by adding energies up and then taking double derivatives and whatever shit like that. You do the same thing, but instead of like seeing it move mechanically, physically, we're just seeing how the voltages move. Right? Let me make that clear actually. When we see the mechanical is so easy because you can observe it. Right? You know what a spring does. It's gonna respond to force, and then it's gonna decompress and oscillate, right? And with a certain dampening rate, eventually it comes to a stop by second order derivative, right?
Yep. You kind of predict it.
You can kind of predict it, but like you can predict it because you've seen it before. And you just draw patterns on how it'll present itself when you change certain things, like the length of the spring, or the metal of the spring, or like the travel of the spring, right? Or the weight on the spring. Like all of that's very predictable. But what I want you guys to keep in mind is when you're doing electrical engineering, in a nutshell, you'd want to understand, I can't physically see this shit, but I can make traces which physically is interpreted or graphically interpreted to show what's happening with the voltages. The voltages will tell you everything you need to know because we are just making a parallel between what the voltage means and what it's like interpreting. We're just drawing a distinction between this is how this sensor works and this is what it's recording. And this is the behavior that it does that. Now, an ECU just says, plug that shit into me and let me look at how all of that works in relation to each other. It doesn't even know what an engine is. Just know that. Like an ECU, a Motec has never seen an engine in its life. It never will. But somehow it knows what to do with it and conduct it perfectly. It doesn't need to know what it looks like. It just needs to know what those voltages do, right? Yeah, every sensor is like an instrument in an orchestra. And, or it's like having good ears. And then having actuators or things that act based on triggers are like the instruments. It doesn't know, like you can't have a good musician play music if you don't have the ear for good music. You know, it's like being tone deaf. You think you're singing good, but you don't hear yourself singing. There's no feedback loop. Then you're not going to change the strain on your vocal cords to make intonations or, you know, raise your voice, lower your voice, go an octave higher, knowing you're off. Draw that, like that comparison, draw that with an engine. And that's probably the best way I can put it, actually. Right? The ECU is the orchestrator. He depends on his ears, the sensors, to tell the woodwinds, the brass, the percussion, when and how, and even on tempo, on rhythm, what the fuck to do. Right? Does that make sense? So I'll leave it at that, and if you guys are interested in like the higher engine theory stuff, that's not till. You're gonna have to wait because that's not till
That's my favorite.
advanced engine theory will probably be 7 and 8. So for all you mechanical engineers, get into like the Carnot cycle, the adiabatic, the exothermic, and all that stuff.
Just saying a bunch of words that keep on triggering memories in my head. Carnot
Just-
cycle.
just- Yeah, I remember that shit from a long time ago, but it haunted me again when I prepared notes for you guys, because it's in the Mtron. If I show you guys the Mtron lectures, you guys are gonna want to know what we're going over now, so that when I give you guys the link to the Mtron training, you guys can kind of like get up to speed more. And I know I said a lot, but I hope that you guys did learn something today.
Yeah, I think I have it here somewhere. Some of the stuff you were talking about.
What, the Carnot cycle? Adiabatic compression?
Yeah, it's in here.
Yeah, the work diagram. You can use that actually to,
I don't remember where I have it, but I know I have it somewhere in here. Something like that.
yeah. It's basically manipulating volume and pressure,
Yeah.
right? When to compress something, to create, to harness, to manipulate pressure based on change in volume to introduce more heat. And then when you expand the cylinder, you cool it down, right?
Yeah. It's like,
You can basically, if you can basically determine how efficient an engine is when you draw out that curve, and you look at the work cycle done.
yeah, 'cause
And if you have some stuff that's super narrow, it's not fun. That's how you know that your engine is not exhausting fast enough, not doing enough work. It's not exhausting heat or providing work to the rest of the surroundings
yeah, 'cause
fast enough.
It's like doing this, right? You have your
Mhm.
pressure,
And then you have
every
the
meal,
volume.
your different temperatures, so then it's just like this little square right here.
Yeah. Let's go eat lunch. But if you really want to know how it works, you ever seen this?
How's it going?
Yep, yep. Oh, line.
How can I help you, sir?
Pick up.
TJ.
Phil said you would know. If not, I'll talk to her right now.
What did TJ tell you about the part? Oh, yeah, right here.
Oh, yeah, that's it.
Oh, I'm saying all this stuff.
It's a whole different world. I think he's not a motor man. It's like when I was
There's an electric company?
it's like a whole different like way of seeing how the motor works compared to like
I think doing this is all fun.
yeah, this is 100%. I didn't want to get a little more deep into like calculation and whatnot. Because yesterday when I was going off the calls for a bit, I was gonna be like going back and forth because he was also back and forth with them, so he can clarify because he knows more about, like I said, he's getting into quantum mechanics and stuff. That's why I want to introduce him to KT. I told him he should get into like a job like something very similar to this, but he's like right now.